Alright guys, this is our extra credit video. A couple things I wanted to review when I was walking around looking at your tests. I noticed a lot of us had difficulty with area and perimeter. We just got to remember area is talking about all of the space on the inside, so I'll use blue here. Area represents all of this inside. While perimeter is different, perimeter, which I'll represent in green, is the distance around the outside. Okay, so it's two different things that we're kind of calculating. For perimeter, we just have to add up all the sides. Now, this is a rectangle, so I'm going to get 3x minus 1, but there's technically two sides. Okay, I've seen a lot of students square this. You're not going to square this. You would multiply this by 2 if you think there's two of them. And then you're going to also add 2 times the other one. That's x plus 2. This equation basically kind of comes from or stems from what you guys probably remember from middle school, which is 2 times, 2 times the length plus 2 times the width. Okay, so that's what this equation essentially breaks down to. Alright, so that helps us find the perimeter. Area, slightly different, wants to get that space on the inside, so we do what's called length times width. And to do that, we are actually going to do a box method. We get the x and the 2 on one side, and then we're going to go ahead and get 3x and negative 1 on that side. So we'll go ahead and do area first. 3x and x, that's going to make it 3x squared. Again, those exponents add. X and negative 1 is negative 1x. 3 times 2 is going to give me 6x, and then 2 times a negative 1 is a negative 2. Combine like terms, 6x and negative 1, and we get 3x squared. Then I get minus, 6x and negative 1, so I'm going to write that out, negative 1x plus 6x minus 2. Then we can go ahead and combine these like terms, 6 positive and negative 1, that gives me 3x squared plus 5x minus 2. For the perimeter, we just got to go ahead and distribute the 2. That's going to give me 6x minus 2 plus, distribute the 2, 2x plus 2. Combine like terms, 6x and 2x is 8x, and negative 2 and positive 2 goes to 0, so I just get this for my perimeter. A lot of problems with this question. The first thing we got to realize is I got to put this over 1. We're going to multiply straight across, and then we'll take care of any dividing. So there's two rules going on here. There's the product rule, and then we have the quotient rule. Okay, let's talk about the product rule first. When multiplying, my exponents are going to add. So z to the third and z squared is going to become z to the add, not multiply. There you go, made my first mistake. Z to the 5th power. The t has no one to combine with, so we just write it. And the negative 4 was multiplying a 1 out here, so we leave it with negative 4. The bottom is 1 times t squared, which just gives me t squared. The next rule is our quotient rule. Okay, there we go. The quotient rule basically tells us that we need to subtract our exponents. So the product rule was like this, right? Multiply the exponents add. The quotient rule stated that we would go ahead and subtract. This would become x to the 1st power. So here I have like terms. I have t squared and t squared. You subtract them, they go to t to the 0 power. Basically, they just cancel out, leaving me with 4z to the 5th, negative 4z to the 5th. That's my final answer. Some students struggled with these ones as well. We got to break these down. Okay, when I'm looking at this, I know 2 will go into it, so I'm going to do 2 and 102. And then I'm going to go ahead and see if I can break this down. I know 2 will go into that as well, which gives me 2, and that's going to be 51. And I can't really think of any numbers that go into 51. I can try 2, but that doesn't work. 5 doesn't work. But if I add the numbers together, 5 and 1, they actually add to 6. So I actually know this is going to be divisible by 3. So again, that was a little shortcut. 5 plus 1 is 6, and I know 6 is divisible by 3, so 51 should be divisible by 3. That goes in once, and we get 17. So 3 and 17, these don't break down anymore, so when I'm done, I've cut the line, we can't go any further. And what do I get? I get the like terms of 2, that means I get to pull it out. In the radical behind 3 and 7, but I just got to multiply them back into 51. So 51 didn't help me by pulling anything else out, unfortunately. But we get 2 rad 51. Our next problem is 17 and, not 17, 170. But I'm thinking ahead of myself. We can do 17 times 10. 17 doesn't break down, and 10 breaks down to 2 times 5. Do I have anything to pull out of this? No. Since I don't, I'm just going to leave it as the square root of 170. Ooh, look at this. Okay, the amount of rebels is currently 10,000, okay, but is increasing by 0.25% every day. How many rebels will be there in a year? Okay, well, our equation is y equals, and then we have growth or decay, so we have to figure out which we're dealing with. Increasing is telling me we're dealing with growth. So this is what we're dealing with. We're dealing with growth, and we just want to set up the equation. So our equation is a, and then we get 1 plus, because we're talking about growth, so there's a plus sign, really important, r to the t power. Okay, so when we plug this in, we got to figure out what goes where. A stands for amount or population, so my A value is here. So I get 10,000 right here. 1 plus, now you got to be careful, this is 0.25%. I still have to move the decimal over twice to get into decimal form, even though it has a decimal in it. So I'm really doing 0.0025. Very confusing, okay? You got to be very careful. And that's happening every day. And my question is, how many rebels will be in a year? Okay, well, if it's this year, we have 366 days, but normally we have 365 days. So my equation would be y equals 10,000 times 1 plus 0.0025 raised to the 365th power. And that is a growth. Alright guys, that is it. I hope you enjoyed the video. Thank you.